So we started now.
All right, we are gonna get started. Oh, microphone.
Oh, I turned it off, sorry.
Testing? Cool. Welcome everyone. We realized it's, since our next meeting is until January, it is our holiday COTE meeting. Cheers, everyone. So welcome. This is the third event in our resources and resourcefulness building in Hawaii. Okay, that's not working. Let's try that. There we go. Talking about Earthen, Strawbale, and Hemp construction. So we are COTE, Committee on the Environment, and our snacks today were provided by G70. Thank you. Drinks by AIA Honolulu. If you are online and you're able to join us in person and have on with us, part of our intent in organizing these is building community and getting to know who's here in Honolulu. COTE is a AIA knowledge group committed to sustainability, this official mission statement. I'm chair of this committee. My name is Jill Edelman. I'm an architect here in Honolulu. I'm joined by Gail Suzuki Jones at the Hawaii State Energy Office, Matt Klein of Cosentino, and Scott Schwartzwalder of G70. And our intention is not only education, but again, connecting people across the building industry who are concerned about climate change and interested in finding out how we as the building sector can do something about it. COTE is national. Basically, if there's an AIA chapter and there is interest, there can be a COTE. We are in the process of building. We have a few initiatives that we've been interested in, and we would love your engagement and involvement. So if you are interested, please reach out. And then just a couple of announcements. This is next week. I had a little blurb about this. Hang on a sec. The pursuit of convenience today has led to rampant consumerism, throwaway culture, and monumental waste. Product design and manufacturing is focused on efficiency and low cost with little regard for sustainability. As a result, the linear make-take-waste economy is built on continuously extracting finite resources just to create products destined for landfills. Those of you who are tuned into what's going on in Hawaii, we actually do also have a landfill problem here, where the landfills, both for C&D waste and municipal waste, are closing down, and they're having trouble finding new locations. So this is next week, and registration closes today. So if you're interested, look into that. We mentioned this last time. You can no longer add comments, but it does, the document is there to review. It outlines 12 strategies and 57 actions for locally adapting the impacts of climate change from the island scale down to the individual scale, and includes a resilience strategy, a climate action plan, and in development is a long-term disaster recovery plan. So yes, we are unique as the most remote inhabited landmass. And so while there is a lot to be learned from the mainland, our geography, our history and culture make us unique. Which brings us to our speaker series. We live in this glorious place of abundance that not very long time ago was completely self-sufficient. Obviously, lifestyles have changed, but the current system in which the vast majority of our goods being imported is problematic, to say the least. And the intent of this series is to ask the question, what would it take to build a local building materials economy? We are now on our third event with David Earthen. We'll get in a little bit more about that. And we hope you join us in January and February. January, we have Joy Valenti talking about turning invasive species into structural lumber. And then Kamana Beamer at UH talking about indigenous land management. And without further ado, let me introduce a speaker. So David Earthen, AIA's principal of Northern California-based Arc and Tilt Architects. David is co-chair of AIA's 2030 Commitment Working Group and represents the AIA on the Embodied Carbon Harmonization Optimization Project, a cross-disciplinary coalition towards reducing embodied carbon in the built environment. For the past 10 years, he was director of the California Straw Building Association, which advocates for natural building systems in the building codes, and he published Strawbale Building Details, an illustrated guide for design and construction. So after this talk, you can go out and get that. He's a native of Wisconsin, and he studied architecture at the University of Minnesota and at UC Berkeley. After his presentation, David will be joined. David is remote, sadly. We would love to have him here with us in the islands. But he will be joined by Jim Nicklow, who is here with us, immediate past president of AIA Honolulu. Jim is lead fellow at AIA. He's principal and director of sustainability at Lord Aig Sargent Planning and Design, where he has committed his career to transforming the built environment through leadership and collaboration on significant deep green projects, sustainability, education, and advocacy, and leadership and mentorship. He also serves on the board of the Hawaii Architecture Foundation. So with that, David, the floor is yours.
Let's unmute. Okay, thank you, Jill. Thank you, Jim. Very excited to be here. As I was staring at the screensaver that you put up, I was realizing that the only mistake I made in preparing for this is not being there in person, as you suggested, would have been much better. What a beautiful place that you all live. Of course, I am based here in Northern California, and it is also a beautiful place, as there are many of these around the planet. And it's, of course, our job to protect these. It was fun listening in on the opening. I felt like I was sitting at an AIA East Bay Committee on the Environment meeting with discussions of, firm issues and all electric and lots of other good things that we're all working on towards a better planet. This is a variation on some discussions I've given to the AIA in the past at conferences, and they always have a disclaimer up there that says all of this material is copyrighted. And I quickly add to that that you should feel free to take photos or capture screenshots as you're listening of anything that you want to try to remember. And I can probably, as you saw, it's also being recorded. So there will be some record of what I'm sharing here today. And without further ado, let us go. All of you are aware of the situation we're in and the path that's been mapped out by Architecture 2030 and in 2006 adopted by the American Institute of Architects as our 2030 commitment, and targeting a carbon neutral built environment by the year 2050. And these are just suggestions that if we can reduce our building emissions by closer to 67%, we are in a better position to hit a phase out by 2040. Our friends at Architecture 2030 have noted that our built environment contributes at least 40% of global CO2 emissions. So we, as architects, have some great responsibility. As my mentor, Dan Solomon, once quipped, architects are not such passive bunnies after all. We have a lot of control over what carbon impacts our buildings have. And that, of course, is exciting news for us. So just wanted to cover first briefly the operational side, or energy use intensity, which we're measuring as part of the AIA's 2030 commitment. And that, of course, is, carbon impacts due to HVAC, lighting loads, all the other equipment and plug loads that's going on, the energy needs of our buildings on a day-to-day basis. We again invite all of you, if you haven't already, to sign on to our 2030 commitment. I recently learned that there is a COTE chapter, and at one of their local gatherings, not a single person was a signatory to the 2030 commitment. I'm not going to name that chapter. I'm not going to shame them, nor you, but I do hope that everyone becomes a signatory. This is from our most recent 2022 reporting year, where we achieved overall a 48% predicted energy use intensity reduction, and that is over 3.8 billion square feet of buildings that are reported in our 2022 year. And you can see the progress we've made in increasing the reporting in the program, and we're hitting a bit of a plateau around 50% reductions, and we're hoping that as building electrification and a cleaner grid become priorities, that we can see those percentage reductions continue to increase again. But net zero energy is a target that we all have. Here in California, it's actually mandated that all new residential units achieve net zero energy through rooftop photovoltaics and a clean energy purchase agreement. So some of our zero net energy strategies, these are not anything new to any of you. Good building envelope, controlled daylight, obviously ventilation is a key in your particular climate, efficient systems, and of course, healthy, safe, low carbon materials. And that is really what this presentation this evening, this discussion that we're going to have is all about, is how can we achieve reductions in these 11% of our emissions that are accounted for in building materials, what we call the embodied carbon intensity measured in kilograms of CO2 emitted per meter squared. And embodied carbon is effectively the stuff that our buildings are made of, from the impacts of the raw extraction of the material, whether it's digging it out of the ground or cutting it down as a plant, the transportation of it, the processing of it, and of course energy used while it's being put together as a building. And it's a good question, why does this matter? For the past 30 years, we've made remarkable progress in the increases in energy efficiency and integration of renewable energy systems in our buildings. But as we've done that, and over time, those decreased impacts of the operating carbon mean that the materials and construction are everything. And perhaps more critically, those impacts are up front. They happen before the door is opened and the building is being occupied. So again, as we decrease the operating impacts, everything is frankly materials and construction. And as Jill noted, when you're in a remote location and much of the resources are being brought there from faraway places, there are transportation impacts. Granted, transportation of materials by ship is one of the most efficient ways that we can move things, but still taking advantage of what's right there at hand is, of course, even better. Just to come back to our 2022 by the numbers report from the AIA 2030 commitment, the average building that's being reported, and granted a lot of these are large projects by large firms, is looking at about a 550 kilogram of CO2 per meter squared average. Low-rise buildings average closer to 300, and single-family residential closer to 200 each. So we've seen a steady increase over the 3 years that the commitment has invited firms to voluntarily report their embodied carbon, and a fourfold increase in the number of projects reported from last year to this year. Our own firm has set a goal of calculating embodied carbon for at least 50% of our projects, and we are aggressively targeting carbon storing for at least one of ours. And I'll just note right now, it's extremely difficult to get to that place, but it's one that we really need to target and get to. Just a very brief discussion on some of the tools that are available. We're looking at the life cycle analysis of our buildings, and it's really only a couple of the B phase, the operational energy and water use that are not embodied carbon. Everything else is all about the materials, getting them to the site, repairing things over the life of the building, and then what happens at end of life. These are just a quick glance at a few of the tools that are out there in case you're not familiar with them. The EC3 tool it was recently brought into the Carbon Leadership Forum, and Building Transparency manages it, and it's a free and one of the most popular ones that integrates with Revit and other higher strength CAD programs. In our firm, we use Vectorworks, and they actually have a plugin for embodied carbon, and also the Beam tool, which is at a right scale for the smaller scale buildings that our firm is typically engaged in. Just wanted to give a quick glance at one of these. This is the Building Emissions Accounting for Materials Estimator from Builders from Climate Action, and our friend Chris Magwood, who is now also with the Rocky Mountain Institute. And just an example of one of our projects. This was a townhome, 4-unit townhome project in Ashland, Oregon. Here, we're featuring Strawbale construction, not only in the exterior walls, but also we're able to get them as the party walls, the sound walls and fire walls between those units. And that combination enabled us to achieve a mere footprint of 21 kilograms CO2 emitted per meter squared. So that was getting closer to zero, but not quite there, but a significant reduction over where we're at. One of the nice things with the Beam estimator is the information that comes out the other end, some calculation of these metrics, and also just some sense of where you're at and where you need to be getting to. And they, interestingly put 300 at the high end. And as we saw, our current reported building average is even higher than that. So to some of the strategies that we employ in utilizing locally available natural building systems, and some of the ones that are available to you there on the islands of Hawaii. One of the resources that I would point you at is the Carbon Smart Materials Palette. This was created by the Architecture 30 group in collaboration with one of the subcommittees, the Renewable Materials Committee of the Carbon Leadership Forum. But it is organized by discussion of first the higher impact materials and what better choices you can make within those, and then looking at some of the alternates and why they are better and potentially carbon storing. So first, to talk about some of these heavy hitters, the good news is that Portland cement, the basic ingredient in concrete, is and concrete itself is headed towards a great carbon reduction through the use of renewable energy in making the Portland cement, to various admixtures that can reduce its impacts, and some exciting innovations in ways that it can actually store carbon. So we invite you to look at what your local concrete suppliers are doing towards making these reductions. We were able to take the local supplier in Ashland, Oregon, who had never done anything greater than, I think, 35% substitution of Portland cement with fly ash, and used 70% reduction substitution. So it's our job to, as we said, move the needle on these things. So just a few of the earth resources that are available to us as architects. Traditional rammed earth. Some of the oldest cities in the world were built of rammed earth. In seismically active areas, that earth is typically stabilized with some amount of Portland cement or lime. This particular project is in Santa Fe, New Mexico, and we featured it as part of a thermal mass wall on the interior of the building, and also a kiva fireplace. A variation on rammed earth is a sprayed version. So the same mix, but it is applied using gunite technology, where the dry material is moved through a tube with air, and then water is mixed with it right there at the nozzle. Very little water means a much drier application, and that of course can lead to higher strength, and it could be shot in place, screeded off, and be very stable in that particular moment. David Easton, who developed a lot of these technologies in Northern California, sadly passed away a few years ago, but one of his last innovations was developing an earth masonry unit. So the same properties as a concrete block can be built with in the same way, but using significantly less Portland cement in its mix. There's one of projects of ours using that. We've utilized those same blocks as part of low carbon footings in our buildings, again, realizing that concrete does have a role. It's very good at being connected to the earth and not rotting, and supporting our buildings well. But if we can use less of it, and then in certain instances come up with some innovative alternatives, that would always be welcome. Our engineers are supporting us in using what's commonly known as rubble trench, some type of compacted gravel to substitute part of the depth of the required footings. A friend, an architect in Bali, Jenny Cardinal, and you'll see some of the other work that Jenny's done on a tropical island, which I thought was very appropriate to share with you here this evening. She, using a system from Darcy Mesner, an architect and engineer here in Northern California, who did a lot of innovative work bringing Strawbale construction to Pakistan post-earthquake, does footings, and in this case wraps them with some form of mesh. In Bali, discarded fishing nets were a commonly available resource, and they can be wrapped around the base of the footing and then brought directly up into the plaster finishes to create a seismically sound connection between the two. Our firm has been doing more and more projects with clay floor slabs, and I am guessing that you have access to clay because there are very few corners of the earth that don't have clay within a 10-mile radius of them. On this particular project, it was found on site, as we have in just about all of our projects. And if it's not directly on site, it can be found not too far away. Clay is typically mixed with coarse sand and a chopped straw or some other fiber as a reinforcing, and 2 to 3 inch base layer with a 3/4 inch topping coat and an application of linseed oil to stabilize. Returning to some of the high impact materials, steel, common in our buildings. Again, the good news is that there are steel manufacturers that are working with renewable energy resources, one in the Pacific Northwest, which is largely hydro-powered electricity-based steel. So ways of utilizing recycled resources and less energy in its manufacture or remanufacture. In one of our projects, we were able to do a comparison between a straight up steel I-beam truss versus a hybrid, where we utilized some amount of steel along with quite a bit of wood, presented this information to our clients, and they considered that and cost, which was actually more expensive for the wood hybrid, but I think they liked the better choice from a carbon perspective, and honestly also liked the look of the wood better than the straight up steel. But nonetheless, some amount of savings in the carbon emitted by making a choice to use wood instead of steel to some degree. And steel still being used because it does have some excellent properties, obviously in tension in particular. Returning to the carbon smart materials palette, just a few of the resources that are discussed there, and a few of these we'll be looking at here this evening. So why are we so excited about plants as a building resource? Well, very simply, they're one of the most efficient ways that we pull carbon out of the atmosphere. I say we, the planet and its living systems pull carbon dioxide out of the atmosphere through photosynthesis. They release the oxygen and store the carbon in the plants themselves, as well as a good amount that gets drawn down into the soil. And the good news is that there are a lot of plant-based carbon storing materials out there, and that they are generally healthier and safer as well, and can be found, grown, harvested locally in many cases. Just to pick on one example or one resource, grain straw, there's enough grown globally to meet all of our insulation needs, as well as offset all transportation emissions. So these resources are ubiquitous and plentiful. And while wood is the most commonly thought of one, there are others that are on a more rapidly renewable cycle, straw, bamboo, hemp being the ones that we're discussing here. Starting with bamboo. And this is an example of the work of a Colombian architect, Simón Valdés, just amazing structures employing timber bamboo. Here in Northern California, we have a company that is taking that timber bamboo and laminating it as part of a panel system to create strong buildings that are structurally supported with both an inside face and an outside face, and no need for studs. So a perfect wall in terms of thermal transfer and a utilization of a rapidly renewable carbon storing resource. An example of a home here in Northern California built of that BAMCore wall system. Talking a bit about bamboo and straw, again, Jenny Cardinal, an architect on Bali, was able to utilize bamboo as part of a project that they did there, but cautions that bamboo does need to be treated in order for it to not be susceptible to both moisture damage and insects. She was quick to note that nothing eats rice straw in her experience, but that bamboo does need to be protected. And the method that they recommended is a Boucheret bamboo treatment procedure, which is the addition of borate and boric acid that can be introduced to the bamboo, and I think she said 5 minutes per meter is the rate at which they were able to do the treatment, and it was very effective. So guessing that bamboo is or could be a resource there on the islands, just cautioning that it needs to be used with some form of treatment. Turning now to hempcrete as one of the forms of building with hemp. And this is a process where the hemp hurd, which is the starchy center of the stalk that's left over after the primary resource for growing hemp has been removed. Those are the fibers that are around the outer surface of the main stalk, and decortification is the process by which those fibers are removed, and then what's left in the center, that starchy bit, can be chopped up and then mixed with a lime binder. Various types of lime can be used as part of that solution, mixed with water, and then placed into formwork, not unlike the way that rammed earth is done, though typically done around studs or some other structural system. The hempcrete, once the hemp fibers are encased in lime, are very stable, moisture resistant, This is an example of a home in North Carolina, which is, of course, a very hot and humid climate and a very popular building technique in that particular location. This is a larger scale project in the UK, also known for its humidity and rain, and very successful use of the material taken to a larger scale. Somewhat of a variation on those resources is light straw clay, where loose straw is dipped into a clay solution and is similarly tamped into formwork. Typically, formwork starts at the bottom of the wall and moves its way up, and it dries and is stable enough as one goes to be able to just simply lift the formwork over the course of the setting of that raw material. Light straw clay is in the International Residential Code now. It's Appendix AR, so there are guidelines for code officials to look to if you're considering doing this. Our friend Paula Baker-Laporte has done a lot of beautiful work with a hybrid of timber frame construction and the light straw clay. This particular example is in New Mexico, but she and her husband, Robert, who's a timber framer, moved to Oregon, which is, of course, a more moist Pacific climate, and with great success. In Bali, Jenny Cardinal has been working more with light straw clay than Strawbale since that initial project, in part because they are not baling their straw, so it can be utilized as a resource more directly out of the field. And she feels the encasing it in the clay slip is an even better way to work with the material. Variations on mixtures of clay and straw include adobe, of course, a traditional material utilized in the American West. This is an example in Northern California, and cob, popular in the Middle Ages in England, but still being utilized today throughout the world, is basically working with the same straw clay adobe mix, just building with it while it's still wet and in a massive form. Happy to say that members of our California Straw Building Association happened to be at the International Code Council hearings when it was discussed the possibility of removing adobe from the building code. It's been there since the 1940s, and it is still there today because they were there advocating for straw bale and light straw clay. So now we'll turn our attention to, our favorite building material here in our firm, straw bale construction. We like to say we have many tools in the toolbox, but I will admit that this one's by far our favorite. Straw bale is not our invention, nor is it new. It is, however, a uniquely American invention. So like democracy and jazz, we've exported it all around the world. And I think it's one of the great contributions that we've made and continue to make. But it was started in the Great Plains in the late 1800s, about the time that baling equipment was invented, and some clever individual realized that we had these big fuzzy bricks and they could be stacked up to build the walls of buildings, and straw bale construction was born. A more recent project, but still, knocking on the door of 85 years old, is a mansion, now a museum in Huntsville, Alabama. So once again, a more moist environment. In that case, the straw bales were used not only in the walls, but actually between the floors and as roof insulation. Many, many benefits. I won't go into great detail on all of these benefits, but I think the one that we're currently most excited about is its ability to store carbon as a rapidly renewable resource. And you don't have to just take our word for it. The U.S. Department of Energy, in a recent call for grant proposals for carbon storing materials, noted hemp, bamboo, wood, and straw as having some of the greatest potential for storing carbon in our common building materials. And I just love the fact that straw made its way onto a chart with the term common building materials. Made my day. How does this work and to what degree? Well, remarkably, for every pound of straw, 1.62 pounds of CO2 are removed from the atmosphere. And that is, of course, because of the release of the oxygen and the storing of the carbon. Your typical home is going to store roughly 10 tons of CO2. Strawbale is also in the International Residential Code. It's been there since 2015. Our team of code people at CASBA are working on getting it into the International Building Code, but we've done several non-residential, commercial, and institutional buildings, and have been able to point code officials to this section, and they see it as something that they can rely on because it came from the International Code Council. Jill referenced the detail book that the California Straw Building Association has published, so recommend you order it from our strawbuilding.org website if you're interested in bringing a lot of these technologies to your projects. One benefit that I will make specific mention of is what I think is the real key to the success of Strawbale construction in creating thermally comfortable buildings is the way that there is a 12-hour time lag of the transfer of heat from the outer surfaces of the Strawbale wall to the center. And it's that inverse, that green line that's measuring the center of the wall relative to the diurnal temperature swings of the exterior, going from this site from the 50s well into the 90s on the exterior, but staying, between 70 and 77 degrees, a nice comfortable climate on the interior. So that thermal mass effect is not to be underestimated. Worthy of mention, especially given recent disasters in your region, is the fire safety qualities of Strawbale construction. So it has been tested to a 2-hour fire-rated wall. That's with a lime plaster on 3-string rice straw bales on edge. But it's also proven itself through several wildfires and buildings that have survived. This is a photograph taken by a client of ours the morning after. He and a neighbor were able to take shelter in and survive the fire in his newly built Strawbale home. Through the course of the night, they watched the fires ignite his off-grid photovoltaic power system, which was located inside of a steel shipping container. But the perimeter of the home with a fire-safe, defensible space around it, and columns that were redwood trunk columns that had been salvaged from a fire, so they actually had some fire-resistant properties. My wife and partner, Annie Tilt, and I are currently engaged in a fire rebuild project of our own. Unfortunately, had a shared family property in Sonoma County that burned in the glass fire of 2020. But we're in the process of rebuilding and have quite a few fire-safe features that are part of this project. But also we're able to utilize a lot of locally available resources, starting with Earth Block, the watershed block now known as Ecoterra Block for the foundations. And our project started by hosting a portable block making rig demonstration that was created by the Rammed Earthworks team. And it was fun to make the blocks on site. The raw material for the soil came from a quarry about 10 miles away. So they're thinking and referring to it as watershed materials is that you should be able to find a resource to be able to make block with within your own watershed. So we utilized quite a bit of that as part of our new foundation. We were also able to take several of the trees, Douglas fir trees that were killed in the wildfire, And within a few years, before the beetles really set in, that timber can be utilized. So while some trees were cut and hauled off site, we did have some of the site lumber harvested and milled in place. Had to hire a timber grader to come out to the site and look at all four sides of every piece of wood and stamp it. And then we were able to utilize it as part of our rebuild project. One of the signatures in our firm is to try to use a live trunk of tree in every project. So this is me making the cut on the entry porch column from a coast live oak that we utilized, one that had been killed in the fire. This rebuild project features a sand bed utilizing solar hot water collectors and circulating that heat in a 2-foot deep insulated bed of sand. We insulated underneath that space with pumice, and we've started substituting pumice for foam insulation board wherever possible. You just need to use a little bit more of it, but it is a stable, it can be a substitution for base rock, and it has insulative properties of about R1 per inch. We then lined that sand bed with salvaged billboard tarp. In this case, we were particularly pleased that it was advertising for a radiant floor system. Just random that the billboardtarp.com billboard that they sent us happened to be for radiant heat. And then there you could see some of the hydronic PEX tubing going into the middle of that solar sand bed. A few weeks ago, we had our straw bale raising. Here, the bales are being used on edge, and we're doing a unique system of installing them on the exterior rather than the interior, so that the clay plaster finish will be, and the straw bales will be our first defense against a future wildfire. And that's where we're at with our own rebuilding project, which is very exciting to see that taking place. In a webinar that I gave to Find Home Building on building in high-risk fire zones, we highlight a lot of the survivors. So there is the link to the Find Home Building webinar. So if you're doing any projects in high-risk fire zones, of which, you know, as the fire marshal in California quipped, nearly every acre is becoming a high-risk fire zone, it's something to be cognizant of and take to heart with every project. Just to go a little deeper on where straw bale and timber is headed, I think taking this technology to scale really relies on turning them into building products. Prefabricated panels show some of the greatest promise. This is the Endeavour Center in Ontario, putting panels together. ModCell is a similar product in the UK, where they have a timber frame and straw bale infilled. They usually utilize a window unit as a part of each panel. Eco Cocoon is being fabricated in Eastern Europe. Bjorn Kjellrup is an architect there who has created a factory-based system, and we're excited to bring that to the West Coast. There have been a few other North American projects, but ours is, I believe, the first in a seismically active area. So this is a new residence with an accessory dwelling unit in Palo Alto, California. And we worked with their factory people to build a SketchUp model. That's the interface that they use to get the proper dimensions on all of the panels. And those were shipped by boat and then train, and then the last mile by truck from the Oakland shipping port to Palo Alto. And here they are being assembled on site. Returning to straw bale construction in a tropical climate, again, architect Jenny Cardinal in Bali created this beautiful example utilizing nearly entirely, well, no, it is entirely locally procured resources. Starting with the straw bales, rice straw, and it is her firm belief that rice, because it grows in a high moisture environment, is actually a superior choice. And fortunately, there's quite a strong rice culture there. And so it is being grown, and I suspect it's being grown on the Hawaiian Islands as well. However, it's grown in Bali in paddies, and harvesting rice with a straw bale baler is not really an option. So they utilized a rig pioneered in Pakistan to make straw bales by hand. Here you can see that work being done. Great care being taken to keep them dry. The simple rules with straw bale construction are good shoes, good hat, and a coat that breathes. So good shoes is a foundation that keeps the bales up away from the ground. And in Bali, they actually made a taller foundation than was required toward that effect and dealing with heavy rains. A good hat is a broad overhang, and you'll see in the finished product the timber bamboo trusses cantilever out quite some distance to keep most of the wind-driven rain off the building. And finally, a coat that breathes is a vapor permeable finish that allows for moisture to get in and get out again. And Jenny notes that they've measured the moisture content at 17 to 18%. Sustained moisture content greater than 20% is when we begin to see dry rot happen in wood products. It's also where we see compost begin to take place in straw bale. So quite effective. Here, a local clay plaster was mixed with cactus juice. In the recipe book for the cactus juice, it suggests that you should utilize it within 3 days. They found that it should be used within a single day, or it really begins to go bad and smell awful. Jenny has also worked with cow poop as an admixture to create greater adhesion, stickiness within the clay plasters. But there you can see the work being applied, first to the raw bales and then a brown coat. They did put more fishing net into that second brown coat, lapped up from the foundation as we saw earlier, and then a finished coat there in the last photo. And really just a beautiful example of well-ventilated natural structure in a tropical climate. So I was very grateful that Jenny was able to share some of this example with us. Returning to other carbon storing resources, ones that we're all perhaps a little more familiar with and comfortable building with is wood. And here at our Esalen Institute project in Big Sur, utilized a lot of FSC certified lumber along with salvaged resources, while the roof spanning trusses here are new glulams. The ones on the wall and the ones that created the bench were salvaged from part of the building that was demolished. And then the redwood spent most of its life, it grew in California, then made pickles as part of pickle barrels in New York, and then currently in Wisconsin, woodworker friend has it there, but we contracted with them to make the acoustic ceiling panels, so brought that redwood home. So again, being conscious of the forestry practices that are behind those materials, looking to salvage resources wherever possible. This is vinegar barrel material utilized. Tall timber is becoming more and more common. This is a 9-story building in Minneapolis. There's a 21-story being just finished now in Milwaukee. Cross-laminated timber is a way of utilizing wood resources to create spanning capabilities, utilizing a lot of that storage. But of course, we don't have enough wood to meet all of our needs, substituting for concrete and steel. So we're looking to perhaps laminated bamboo and lesser utilized wood resources such as eucalyptus to create mass timber or mass bamboo products. Next, I want to turn to some of the best opportunities to utilize some of these plant-based resources. That would be in the form of insulation products. There is a whole section in the materials palette dedicated to insulation, and you can see the relative carbon emitting impacts of a lot of common materials that require energy and petroleum-based resources in their manufacture, and sometimes greenhouse gas emitting compounds in the blowing agents. And then we can look to the lower edge of the chart where these natural plant-based resources have carbon storing properties. So most commonly available ones to substitute into projects, cellulose, blown in, sprayed in, sheep's wool. Hemp wool is another way of utilizing hemp. Group in Idaho, Hempitecture, is marketing a bat product made of hemp wool. Lesser known ones, but ones that are coming online, utilizing chopped straw. Our structural engineering partners here have a panel they call the Verdant panel, which they're infilling with chopped straw and targeting an R value of 4 per inch. I'll believe that when I see it, but I think if they even get to 3, they'll have a competitive system. The rice hulls, we're looking to do our first project, dumping rice hulls in between BAM-core panels for insulation in a project. And then loose fill is a form of wool, sheep's wool that's available. Some interesting emerging products that we look forward to: mycelium, mushrooms, being utilized, other forms of plants, in this case, a root mat that's been dried out, has the property of trapping air in small spaces, which is what insulation does, and then perhaps a corncob based board. Looking at the sheathing and envelope wrap, cork, which is also quite durable and weather resistant, compressed straw, wood fiber board, now a company in Maine that's manufacturing a wood fiber board, so we no longer have to get it from Germany. Looking at plant-based resources for exterior cladding, once again, cork can be utilized in that way as well. And then some other systems that are coming online. Faswall or Durasol is a wood chip based insulated concrete form. Stack Block is a compressed straw product, and there's a rice straw MDF available in Northern California. We utilize this for the wall finishes in a recent farm worker housing project. The wall on the left is Strawbale with a lime plaster, but the wall on the right, shown in detail, is this rice straw based MDF with a sealer on it. And that's that farm worker housing project. Once again, the beam calculator, we were able to show how much carbon storing we could get from those exterior walls and the cellulose insulation in the roof, but not enough to offset the impacts. One of the nice outputs from the beam estimator is it's highlighting where some of your higher impact materials are, and we were somewhat surprised to find the aluminum clad wood windows, both the glass and the aluminum cladding added up to the highest impact in this particular project. So where we're hoping to get with this material, these materials and carbon storing in our buildings, is a hope that buildings, which if there's anything we humans are going to continue doing, it's creating shelter for our growing needs, is that the buildings may become the Earth's 6th carbon sink. So I won't detail what the other 5 natural ones are, but that's our goal. Just to wrap up with a few examples of projects that have targeted this and integrated some of these materials. This is a 34,000 square foot mixed use office, warehouse, and production building in Eugene, Oregon, remarkably built for $147 a square foot. And in the straw and wood frame walls, we were able to store 10,000 kilograms of CO2 versus what would have been, I think, closer to 70,000 emitted if we'd done steel studs with fiberglass and a foam insulation wrap. So the two upper floors of the front of this building are what feature the Strawbale and clay insulation on the interior. Just a few other salvage resources worth mentioning: used windows along this interior corridor where daylight is allowed to penetrate into the backside of those offices, used gymnasium flooring for the hallways, and offcuts from a local cross-laminated timber factory that we utilized as stair treads. Then the bales here placed on end between studs, what we call the baubs system, held in place with plywood strips and long screws, and then finished with a clay plaster. Half of the clay was able to be harvested on site as part of the excavation for the project. The other half brought in locally, and our clay artisan leader, Erica Ann Bush, architect and builder in Eugene, did this beautiful artwork of the Mahonia plant and the clay plaster in the community room of that building. This example is in Palo Alto, here featuring a eucalyptus column and shaping the building around an existing grove of trees for a climate responsive, usable courtyard with natural shade, and then integrating shading to the degree possible, combined with natural ventilation and photovoltaic and other resources that power the building for a net zero energy footprint. Here we utilized a mineral wool wrap of the building, so not a carbon storing resource, but one that actually has some pretty significant fire resistive qualities that were important in this particular location. And then again, various solar systems providing free heat on the hot water and all the electricity the home needs. This next example is a middle school classroom in Carmel, so coastal California, and again, integrating both solar hot water collectors and photovoltaics. Careful attention paid to daylight and balancing solar gain with thermal mass, and then utilizing natural ventilation, which is, of course, one of the great tools that you have in your toolboxes. But this was a light monitor near the rear of the classroom that allowed for that balanced and bounced daylight as well as ventilation. And then the classroom itself opening up onto a science and cooking garden habitat features these garage doors that can literally open the building up and connect it to its landscape, which is something that I believe all buildings need to do a better job of. We targeted a carbon storing project in the form of a prototype, which I do hope to see some variation of this built one day, but this is 3 stories of residential over retail and parking podium, designed as an infill project for here at the Bay Area, and utilizing aggressively low cement concrete, substituting other things for concrete, including some of the earth block, CLT podium deck, Strawbale walls and for insulation and other products, and then utilization of wood and hybrid wood buckling resistant brace frames for the seismic bracing of that ground floor. And we're able to show on paper a predicted carbon storing of 10 kilograms CO2e per meter squared. Great project funded by our local waste management authority and partnered with ARAP and our structural engineering partners. And just to show an example, this is not one of our projects, but a 7-story housing project in France, where they utilized straw bales encased in wood fiberboard boxes as part of the insulation and cladding support system, and otherwise utilized a CLT floor and wall structure and showed that the wood and straw in the building far offset the emissions of the concrete and steel. And you can see in this diagram that even if you considered the wood to be a carbon neutral resource, that straw alone did the offsetting of the concrete and steel. So if there's nothing else I want you to take away from this discussion this evening, it would be these 7 words: build shelter, not too big, mostly plants. And my thanks and apologies to Michael Pollan, who wrote a similar phrase for his food rules book. Some of the resources discussed here are available at these websites. And we can put that back up again if we need. I want to acknowledge some of our colleagues, Aaron McDade, who serves with me on the 2020 Commitment Working Group, and my partner, Annie Tilt, here at Ark+Tilt. And I probably should have added Jenny Cardinal down in Bali to this list as well. Contact information if you want to follow up with any questions or check out the Straw Building Association's website. And once again, a pitch to join the 2030 commitment of the AIA and start reporting your portfolio of projects into the Design Data Exchange. And I thank you very much and look forward to following up discussion with Jim.
Well, I want to thank Jill and the committee for putting together such an informative and interesting series of lectures, and thank you, David, for what's a really interesting presentation. I know we've got folks joining online and folks in the room. If you're remote, you have the option of either unmuting yourself or dropping a question in the chat. I'm going to take moderator's prerogative and ask the first question before I open it up. A lot of the systems you showed, David, were kind of reliant on local site fabrication and non-traditional systems and measures. I'm curious about sort of building capacity locally to do some of these different materials. If you could share a little bit about how you go about doing that, because you share projects in lots of different locations, so presumably you're doing some kind of capacity building as part of the projects. I'd love to hear more about that.
Yeah, no, it's a great question and an important one. You know, we have a informal motto in the California Straw Building Association, which is, you know, it ain't rocket science. It's actually not that difficult to work with this material, to understand it and utilize it. We quickly add that it is building science, and so being smart about it is really key. And for some of those hybrid systems where we have the bales installed against plywood walls, we've actually run WUFI analysis just to make sure that we're not creating any moisture problems with those. The Straw Building Association does host workshops and trainings where we invite people to come learn hands-on. We have a pro course series that we can train professionals in learning about how to utilize some of these resources. We rely on a network of plaster experts who are skilled at going out and looking at the soil that's on a site and determining whether or not it is usable, what proportions of sand and chopped fiber need to be added to make sure that they're the right mix. So it's creating a network, a community of people. Here on the West Coast, there has been a plasterers guild that's been created, and they get together and they share information. We have annual conferences, and we're finding more and more architects and builders are attending our conferences, where not only Strawbale but plasters and other types of building systems are being discussed. What I think it's really going to take, in addition to these communities of knowledge, is our product manufacturers really embracing these as the resources, the raw materials to make products. Because when I look at doing a large building by a large firm out of Strawbale, and the specification writer, the first phrase is, well, go find a local farmer and see what types of bales they have. I mean, their mind is blown at that moment. But if they can, look to a company like EcoCocone, who has a prefabricated straw panel that has structural, characteristics that are documented, and it has tests, or a product like the BAMCore where they've done, structural testing, they've got an EPD and an ES report and other things. It just makes it a more utilization a little more feasible for certain building types. But when it comes down to it, one of the favorite things that I get to do as an architect is lead a group of volunteers in placing the straw bales, or mixing and placing the clay floors, and bringing people who don't normally get to engage in the building process, and bring them into it. And it's just a delight. So I just have to make mention of the community building quality that comes with some of these materials. So I don't know if that completely answers, but it hopefully gives a little bit of insight into, how we've been able to make it happen here, and probably, something you would need to start to generate on the islands.
Thank you. Any questions in the room or online?
There is one question online. David, could you share, some, any more enduring examples of Strawbale projects? So I guess ones that have been around for a while.
Well, I did share a good number of them. I don't have those at my fingertips, but Jenny and I actually met at the International Straw Building Conference in New Zealand, and there are quite a few on the islands there, and into Australia. Now, granted, not all of those places are either tropical nor high moisture content. James Henderson, I mentioned, who is the leader of the Plasters Guild, works out of the Olympic Peninsula in Washington State, which is, of course, a very high moisture climate. And there they found that buildings that are conditioned survive quite well, but if they're left unconditioned, they begin to see problems. But as David Eisenberg, who was part of the launch of the modern revival of Strawbale and continues to be one of our key code advisors, likes to say, you should only build with Strawbale in a dry place, and you can make a dry place anywhere. So just know that it can be utilized with, again, some building science behind it. And I know they've been built in every U.S. state, and I believe that includes Hawaii. So there is that example. We've done some projects in Alaska with Strawbale, granted in the drier part of that state, but I know that there are some on the Kenai Peninsula, which is a little wetter.
Actually, I was wondering if you have an opinion. One thing I've heard, because Strawbale is agricultural waste, right? Predominantly, is that accurate?
Yeah, the key distinction is that we're building with straw and not hay. As we like to say in Casbah, hay is for horses and straw is for houses. Straw is the leftover stalk, the chaff, after the seed head has been harvested, be it wheat, oat, barley, rye, or rice. And we've built with all of those, but here in Northern California, it's primarily rice. So what's baled is the stalk that's left over at the end of the harvest season, and then the straw can be utilized for erosion control. It can be used for bedding for animals. Some of the straw is left in the field, and the fields are flooded for habitat for migrating birds. So various things are done. Traditionally, the straw was burned off the fields, and the burnt straw would fertilize the soil. But the EPA told California rice farmers that burning their straw was no longer going to be allowed. And that's actually when guidelines for building with it came into the local codes here. And since then, that was 1995. Again, in 2015, made their way into our California residential code.
Yeah, one of our literally locally grown building products here in Hawaii, I'm not sure if you're familiar with, was cane. Sugar cane was one of our main agricultural staples for quite some time, and the waste cane they stamped into panels. I think arsenic was added for insect resistance, but it's a super common material in houses from the 60s to I think into the late 70s.
And still being manufactured or no?
No, I don't know if the arsenic is the reason it's no longer, well, but in the sugarcane industry, there's no more sugarcane to make it.
Right. But that would seem like an opportunity for a crop like hemp or bamboo to utilize. I know a lot of the bamboo that Bamcor is using, they now have a production facility in Florida, is being grown on former tobacco farms in the Southeast. So, it could be that a lot of that sugarcane growing lands could be transitioned into some other local resource that are both food producing and resource producing.
That's sort of where my question was going is hemp versus straw. So there is a push for, legislated for more local food here. And have you seen the conflict between, whereas hemp has all these amazing qualities as a building product, but it isn't food first. And should Strawbale be privileged because it provides and building material as opposed to hemp, which is building material? Have you seen that conversation? Or should this instead of that, we've got the double benefit? So
I have not heard that the Idaho potato farmers are concerned that the hemp people who are growing hemp for hempcrete and the hemp wool are taking over their lands too rapidly. But no, all kidding aside, I would think that the growing of rice for food and then utilizing the byproduct would be the most natural way of getting a both and out of it. But I think there are many great qualities to hemp that should not be ignored. So, and if there is hemp being grown for cannabis or cannabis related products, that can be used for hempcrete, I know for sure, for the chopped up herd. But I would be surprised if it couldn't be used for the wool product as well. So, maybe someone in hempitecture is ready to get out of Idaho and move to Hawaii and open a local branch.
yeah, there is actually a fair amount of hemp growing going on in investigation. There are a couple more questions here online. Any thoughts on how to get buy clean policies as there are in California into Hawaii?
Well, I know here in California, there was quite a lobbying effort, including our state architect, who did a great job of helping to promote it with the legislators there. Similar effort in Washington State. I would look to the policy division at the Carbon Leadership Forum for guidance in how they were able to help see these things happen, and then use those as a model.
Yeah, I think it's the dimension of growing food versus growing building products, I think is really interesting, because that hasn't the local discussion with these former sugarcane fields has been about food. I think it's an interesting question to get daylight a little bit more as an organization, fiber growing opportunities. And I think the Maui fires, I think, a big part of the problem was invasive California grass that kind of took over where the managed sugarcane fields had been.
Yeah, you mentioned a very good thing, which is that there are products that can be made from hemp that aren't necessarily food, but they are of value and would otherwise be resources that are likely being, shipped to the island. So if you're looking at a more fully sustainable and self-sufficient economy, it should include resources that provide those other needs. And if they can have multiple layers of benefits and provide building materials as well as clothing, great.
There's more comment here, which is someone saying they're going to look into rice straw in Hawaii, where the first commercial rice sale in 60 years was made for Hawaii.
Huh. Yeah, I'm not surprised to hear that. I know that spam sushi is a big hit in Hawaii, and half the ingredients to that are rice. So, kidding. I'm revealing my limited knowledge of Hawaii right there, as a native Upper Midwesterner. Clearly, I need to get there.
You become 7-Eleven has vegetarian.
Oh, nice. Yeah, there's a biofuel station in Eugene, Oregon that sells the best tempeh Reuben you'll ever have.
We're doing it in time.
Well, we're over time. Yeah, we're well over time. So thank you everyone online and everyone here for sticking around. I don't know if you had questions.
I have more questions, but maybe we'll take them up offline. I saw your involvement with the Real Goods Solar Learning Center in your earlier career, and it's really interesting to see that. I remember encountering that magazine in architecture school. So you have a long career of informing ecological design that it's really interesting to see.
Yeah.
Get to that today.
I had been doing some city planning scale work with Sim van der Rijn when Real Goods, and former state architect Sim van der Rijn, and also a professor at Berkeley, which is how we met. And we proposed a building with these long curved rammed earth walls. And one of the techs at Real Goods said, how about if we did those out of Strawbale? And, neither of us had ever heard of Strawbale construction, but we said, yeah, sure, why not? And worked with our engineer, Bruce King, and really came to rekindle my love of architecture, as well as what I never saw coming, which was a lifelong pursuit of Strawbale as a building material. So, but that's where it all started, was the Solar Living Center. And that one graph I showed with the effects of thermal mass, that was taken from a study that some UC Berkeley students did at the Real Goods building.
Thank you for a career of influential work and for coming to join us today. And we hope you'll come in person.
Well, thank you for the invitation, both to be here tonight and to get there one day. And I think I will. But it's really a delightful conversation. Thanks again for having me be a part of it. And your series looks great. I'm sorry I missed the first two, and we'll try to tune in for the latter two.
Well, yeah, thank you, everyone. I think, thank you, Jim.
Thanks, David.
Thank you, David.
Yeah.
This will get posted to the AIA Honolulu YouTube channel. So if there are slides that you missed and you want to go check out, be able to find them there. And I think that's it for this evening. Thank you, everybody, for sticking around. Thanks for coming.
So,
Hey, good night, all.
thank you.